Hello and welcome to this video about formulas and names, part 1. We're splitting this up because there is a lot to talk about with formulas and names. So in this video, we're going to start by looking at oxidation numbers, and we are going to write formulas and name binary ionic compounds. This is just an interesting representation of elements that was used in very early times to identify known substances using pictorial symbols. And that's not what we're going to do. We are going to write chemical formulas and we're going to name compounds. And for both ionic and covalent compounds, we can write names from the chemical formula, or we can write a chemical formula using the name. And in this video, we're going to look just at the binary ionic compounds. In order to name binary ionic compounds, we have to learn about something called an oxidation number. And an oxidation number only indicates how many electrons an atom has gained, lost, or shared in order to become stable. It doesn't have anything to do with oxygen, but it has to do with the numbers of electrons that have either been transferred or shared in order for an element to achieve stability. It's going to be a positive or a negative number, or it could be zero if it doesn't have an oxidation number. It has no charge whatsoever. You can use the periodic table to predict most oxidation numbers, and we're going to look at how we do that. However, the transition elements are kind of special, and oftentimes transition elements will have multiple different oxidation numbers that they can achieve. And so I will only ask that you learn how to use a table in order to find out what the oxidation number is for different elements. I'm not going to ask that you go around and memorize all the different varieties for the different transition elements. So here is a table that you can use to see what some of those transition elements have for their oxidation number. Notice that when we name the ion, let's say copper, it will have in parentheses, with a Roman numeral inside the parentheses, its oxidation number at that particular time. So when copper has an oxidation number of +1, it is going to have in parentheses a Roman numeral 1. When copper has an oxidation number of +2, it will have in parentheses Roman numeral 2, and so forth and so on. Lead can achieve an oxidation number of +4 sometimes, and so in parentheses it would have Roman numerals 4. And when we name that ion will have after it then this oxidation number in parentheses. Remember, the oxidation number indicates how many electrons something is lost or gained. So you can see that for all of these metals, they have lost electrons in order to achieve this positive oxidation number. For ionic compounds, the oxidation number is simply going to be the charge on the ion. So when we look at the periodic table, we see that sodium is an alkali metal. It has one valence electron, which it will likely lose when it forms a bond with something else. So sodium's oxidation number is going to be +1 because it's going to lose that electron and have a +1 charge. Chlorine is on the other side of the periodic table. Remember, it has 7 valence electrons. So it would really like to gain an extra electron to have a noble gas configuration, and so it is going to have a -1 oxidation number because it's going to gain an electron when it becomes an ion. Magnesium is an alkaline earth metal. It's in the second family, the second column as we look at the periodic table. So it has 2 valence electrons, which it's going to want to lose to achieve stability. And when it loses 2 electrons, it is going to have a +2 charge. So its oxidation number will be a +2. So we've been throwing this word around, binary ionic compounds. A binary ionic compound is simply composed of only 2 kinds of atoms, not more than 2. So how are we going to determine the formula for a binary ionic compound? Well, we're going to combine the ions in a ratio that will yield a neutral compound. Let's look at an example. What if we'd like to combine sodium and chloride together in a compound? We see that sodium has a +1 charge and chloride has a -1 charge. Therefore, they are going to combine in a 1-to-1 ratio. Because remember, we need to have a neutral compound. So this will be the formula for sodium chloride. What if we have oxidation states that aren't just equal? We have a plus something else besides +1. Let's look at magnesium chloride. Let's combine those two ions together. When magnesium bonds to chlorine, we are going to have, let's write this down. Each magnesium ion is a +2 charge. Each chloride ion is a -1 charge. If we combine one magnesium and one chloride, we are going to have +2 here for the magnesium and -1 for the chloride. We're going to have a molecule that is +1 charge. It is not neutral. Therefore, we need to have a ratio that gives us a neutral charge, which means we're going to need 2 chloride ions. Because if we have 2 chloride ions at -1 charge each, that will give us a -1 and another -1 charge. So 2 - 1 - 1 is 0. This would be a neutral compound, and you don't need to write these little charges out there in your final formula. Those are just for while you're figuring out the ratio. Here's some basic rules then for writing your formula for a binary ionic compound. You first always write the symbol of the element with the positive oxidation number. So all metals have positive oxidation numbers. Usually hydrogen does as well. It's usually a +1. Second, we write the symbol of the element with the negative oxidation number. That would be nonmetals. Occasionally hydrogen will have a negative oxidation number when it's bonded to a metal, but that's pretty rare. And then third, you find the ratio of the ions that will yield a neutral compound. You write the number of each type of atom in subscripts. And we omit the number 1. We never write a 1 as a subscript. That's just assumed. So let's try writing the formula for aluminum oxide. I'm going to write the symbol for my element with positive oxidation first. That would be my metal. So I'm going to write the symbol for aluminum. Next, I'm going to write the symbol for my negative oxidation number. It's going to be the oxygen, because oxygen is going to be a -2. If we look up at the periodic table, it will gain 2 electrons. Now, in order to find my ratio of ions that yield a neutral compound, I'm going to have to think about this a little bit. I know that aluminum is going to lose 3 electrons and become +3 charge. I'm going to draw a little picture out here. I know my oxygen is going to be a -2 charge. Those do not cancel out to give me a neutral compound. What if I add another oxygen? And maybe another oxygen, and maybe another aluminum. You can kind of see the math that's going on here. If I have 2 aluminums at a +3 charge each, that gives me a total positive charge of +6. If I have these oxygens with 3 of them at -2 charge each, 2 times 3 is -6. That will give me a neutral compound. Therefore, I need to have these written in these proportions. If I have 2 aluminums, I write a subscript 2 right after the aluminum. If I have 3 oxygens, I'm going to write a subscript 3 for the number of oxygens. This is my neutral binary ionic compound. That's the formula. What if I know the formula and I want to write the name of the compound or say it out loud? How am I going to do that? Well, the first rule for that is to write the name of the positive ion. That's easy. We're just kind of doing this in reverse. The second step is just sort of a note. if that positive ion has more than one oxidation state, remember the transition elements, they can sometimes have more than one oxidation state. So for this step, you need to go back and look at that chart and say, is my ion on this chart? If it is, you're going to have to figure out its oxidation state and write it in Roman numerals in parentheses after the name. The second thing you're going to do after you figure out your positive ion, if it has more than one oxidation state or not, you're going to write the root of the negative ion. So not the full name, but just the root. And then you're going to add an IDE to the end of that. So some examples would be right here. Oxygen would be a negative ion. The way we write its name would be just the root, ox. Not oxygen, but ox. And then we add IDE to the end. Same for phosphorus. If phosphorus is going to be our negative ion, we're going to write phosph and then just the root, and then we'll add an IDE on the end. Same for nitrogen. It becomes nitride, and sulfur becomes sulfide. Let's do a couple of examples together so you can get the hang of this. What is the name for the compound Ca and F2? I won't say it out loud. Let's see if you can pause the video and try and figure that one out on your own based on the rules for naming compounds. Okay, did you have a chance to do that? Let's start by naming the positive ion first. That would be calcium. When I look at the periodic table, calcium is not a transition element. I don't need to go and consult my chart to see if it maybe forms multiple different positive ions. This is pretty easy, so I don't need to write the Roman numerals in parentheses. Now, the next thing I do, I'm going to name my negative ion, which is fluorine. But I'm not going to say fluorine. Remember, I'll just write the root of it, which is fluor, and then I add my ending IDE. Calcium fluoride. Now let's try this problem. What's the name for the compound? This. Pause the video and see if you can do it. All right, let's try it together. First, I name my positive ion, which is going to be copper. Oh, now when I look on the periodic table, copper is a transition element, and I look on my chart, copper can have more than one different oxidation state. So I'm going to need to put something in parentheses after copper, but I don't know what yet. So let's move on and go ahead and name my negative ion. Remember, I write simply the root first, and then I add my IDE. So it's going to be copper something chloride. How am I going to find out what the charge on copper is? What is its oxidation number? Well, I know that chloride is -1 because of where it is on the periodic table. It's going to gain 1 electron. I also can see in this chemical formula that there is 1 copper for every 1 chloride. Therefore, copper has to have a charge of +1 in this situation because there's only 1 of each and I'm forming a neutral compound. So I'm going to write Roman numeral 1 here for the charge on the copper, not because there is 1 copper atom, but because copper has a +1 charge. That's what this represents. It represents the charge on the ion. Advanced ideas. Farmers have been adding compounds to soils to enhance their crops for many, many years. One of those is lime. It's also known as calcium oxide. Can you write the formula for that? You can now. What are some other common fertilizers? What are the active ingredients that make them effective? Can you write their formulas? Another idea, binary ionic compound, iron oxide. It's the naturally magnetic mineral magnetite. Magnetite was used in the ancient world as a compass, and they used to call it lodestone. Find out where the name magnetite comes from. Also, can you tell the chemical name for this mineral? I didn't give the correct name when I was reading this question. Can you write down the correct name for it? Look forward to seeing what you come up with, and we'll see you in class.